Okay, number 3. For this one, see that this is a geometric series. We'll have to use the formula we talked about in class. And now, maybe you think this is not exactly the same because the n starts with from 1 in the question, and this formula n starts from 0. Don't worry, okay? That is not essential. The most important part for you is figuring out what r is. In this case, it is obviously equal to 0.4, and it's less than 1 for sure. And also, remember that a in this formula is just the first term in this series. Okay, no matter what it looks like, the first term is a. So in this question, see that when n is equal to 1, you get 0.4 to the 1, which is 0.4. And that will be the value of a. Okay, so now let's start to do it. It should be equal to a, which is 0.4, divided by 1 minus r, which is again 0.4. And that gives you 0.4 over 0.6. So it's simplified, you get 2 over 3. Remember, try to write down the formula next to your answer. So in case you made a mistake in your calculation, you can get partial credit for writing down this formula. For the second question, it looks complicated, but remember, it is just a sum of 2 series. One is here, the other one is here, and this one is obviously a geometric series, and r is equal to 0.1. But you can figure out what a is by taking n to be 1, so a is also 0.1. Now what is this? You can try to write a few terms in the series, and you'll realize that it is the alternative harmonic series. And we know that this is equal to log of 2. Okay? Okay, now, so to answer this question, you just need to separate these 2 series and rewrite it as a sum of -1 n minus 1 over n, and goes from 1 to infinity, plus (0.1 to n, and goes from 1 to infinity. For the first series, we know that it's equal to log of 2. For the second one, since you already wrote the formula here, you don't have to write it again. For this one, it's equal to a, which is 0.1 over 1 minus r, which is 0.1 again. And that will give you log of 2 plus 1 over 9. Now last question. To answer this question, try to take the partial sum first. sum. That means you are not taking n from 1 to infinity, but 1 to, say, m. The summation is the same. Log 1 plus 1 over n minus log of 1 plus 1 over n plus 1. Write down the terms in this series. The first term, when n equals 1, that will be a log of 2 minus log of, and this is 1 plus 1 over 2. So it is the log of 2 minus log of 3 over 2. This will be our first term. Second term, when n equals 2, you will have log of 3 over 2 minus log of 4 over 3. Sorry, 1 second. When n is 2, 3 over 4 over 3. You can keep going. Write down third term. That will be log 4 over 3 minus log 5 over 4. The last term in this partial sum will be log of 1 plus 1 over m minus log of 1 plus 1 over m plus 1. Once you write down this partial sum, you see that all the terms in between are cancelled. Including this one is cancelled by the term previously. The only thing remained will be the first term, log of 2, and the last term, negative log of 1 plus 1 over m plus 1. And write it here. So this is the partial sum, the nth partial sum of this series. The second step, taking the limit to find the sum of the series. It's a limit when m goes to infinity. Be careful, we're taking the limit when m is going to infinity. M is the upper bound of the index here. the limit of the partial sum, which is log 2 minus log of 1 plus 1 over m plus 1. Now, how to take this limit? We can try to take the limit inside the parentheses first. The limit of 1 over m plus 1 is 0 when m goes to infinity. And then you add to 1, that is 1. And then you take the log of 1, you get 0. So the limit of the whole expression here is just log of 2. Okay, so make sure you know that there are 2 steps to solve this problem. First step, writing down the partial sum. Cancel all the terms in the middle, find the final result. And the second step, taking the limit to find the sum of the series.